Hey, good afternoon, everybody. Am I audible? I'll share my screen.
Yes, you're audible.
Thank you. Let's start. Good afternoon, everybody. Am I audible? Sorry. I'll share my screen.
Yes, you're audible.
Thank you. Okay, actually the YouTube was on. Now, okay, we are streaming on YouTube. Anybody who has bandwidth problem, so you can watch the lecture there also with a small delay of maybe 10 seconds. So today we are going to discuss, about HMMs, but before that, another thing which is essential. Let me start from there. Okay, many of you asked about midsem coding, and some of you also have questions regarding programming. So let me start from there. I'll open my terminal. What I'm going to do is, you have seen the test file, this one, test cases, and the solution file. And now I'm going to give you the program which we are using to evaluate the test cases. Many people have doubts that how are we, means they have some doubts that their programs are not running or something. So let me make it very clear first by opening. How do I do it? I think I can do it by, oh, I have not shared my screen. Let me share my screen first. Give me a second. Let me open Jupyter as well. Okay, so this is a folder. So it has got assignment underscore test underscore 0. This is the test file which you have received. This is the solution file which you have also received, but essentially this will be the solution provided by you, right? So when you are evaluating, so basically what I'm trying to do is I'm trying to give you the program which we are using to evaluate your answers. So this is the answer which you submit, solution.ipnb. These are our test cases, and we use this program evaluate.py to evaluate your answers. So basically, if I give you these things, then you can yourself run the script and see where the marks have been deducted. And I have made a README file for your reference so that you can know how to run the programs. Okay, so let me start from here. So in this folder, we have these three files, evaluate.py, ioparse.py. These will be provided to you. These two files are our program files. And this assignment underscore marks map, this basically is a CSV file, and it contains, I will show you with a text editor. It contains the function name and the corresponding marks that has been assigned to it. Generate data for 10 marks, train with MSE 20 marks, then train BP 30 marks, evaluate 20 marks, right? Now, these are the inputs. Okay, let me first convert my IPNB files to .py files. So we convert the IPNB file which you submit to simple .py files, Python files. How do I do it? It's simple command. Let me just copy from here. Okay, and file name assignment underscore test. Oh, sorry, I have to first go to the folder. So cd and this folder name. Now I can do assignment underscore test. So I converted into a .py file. You can see here. This is .py file is generated. Basically just converted my Python notebook into a simple Python file. And similarly, I'll do it for the solution, basically for the solution which you have submitted. Okay, so you can see solution.ipnb, and now solution.py has been generated. Now, okay, now come to the next step. Now you have to run this script. And okay, to run this script, you will say Python evaluate, and that's it. So you'll say Python evaluate.py. Then your answer file, which is solution.py. Then the evaluation file or the test file, which is assignment underscore test underscore 0.py. Then the marks map file .csv, which is this is the one assignment underscore marks map .csv. So I will say assignment underscore marks map .csv, and then followed by the output file which contains your marks. So for that, I will be just creating a file, marks obtained or marks out .csv. So this program will write the output in this file. Okay, now I will run this program. Okay, it is running your program, and finally total marks are 80. But to see what are those marks, I can open it. Marks out.csv. This file has been generated, and this file I can open with either Microsoft Excel or TextEdit, because it's a CSV file. Let me use TextEdit, simple TextEdit, basic simple text editor. So generate data, I got 10 marks. Train with MSE, I got 20 marks. Train PP, I got 30 marks. Evaluate, I got 20 marks. And if any problem is there, it will be shown on the terminal, on the screen, that okay, like here it is first question is generate data. It is testing generate data. There are 3 tests, all of them are passed. Next, it is testing question train with MSE. It is also everything is matched, the test is passed. The next question is train BP. Then whatever the print command was there to print all the values that the loss is reducing, you can see with the back propagation. And then finally, so the question is evaluate. Question evaluate. There also it is printing whatever we have asked it to print. Finally, the total marks are shown here. So if you make any error when the test case fails, then it will print the error to whatever degree of verbosity you have set. Basically, whatever print commands you have put in the test cases or in the solution file, those will be printed here. So this is a simple way to evaluate your functions. So I hope this process is clear to you. So I'll be sharing with you essentially these 2 files, evaluate.py and ioparse.py, which are our programs, and the input, which is assignment marksmap.csv. And then you already have the test file. You can run it on your solution, whatever you have submitted, and it will show you how many marks you got, where were the marks deducted, everything will be shown. Okay, so this is what I wanted to share with you. Now, is this clear? Is everything clear to you? I will share these in the resources section of MOOCit platform. Let me go to the chat window. If you have any questions, you can write there. Any questions? Any questions at this moment? Anybody has any questions? No questions? Okay, so if this is clear, I will just close everything and we can go to our discussion. So we didn't need Jupyter Notebook actually, that's good. Okay, so in today's discussion, we are going to study HMMs, which is our today's topic. Let's start with Markov models. So what are Markov models? Okay, you have all read probability theory. So you know that my data today it can be independent or it can be dependent on my previous data point. I'll give you an example here. So let's say you have a data point. Let's say you have some, okay, let's take an example. Let's say temperature today. Let's say I'm measuring temperature. Let's say the average temperature today. So average temperature today means okay, yesterday, because today the day is not over yet. Average temperature for day number day D. Okay, sorry, it's too thick. Right, let it be TD. Now, average temperature for time for day D minus 1 will be something like some other value. Now, I ask you the question: is the temperature, average temperature for the day D, is it independent of day D minus 1 or not? Let me replace T with X, because X is our normal notation that we use for X is the normal notation that we use. So my question is, okay, are XD and XD minus 1 independent? What does it mean when I ask this question? Today's temperature is independent of yesterday's temperature, yes or no? Answer is no. Answer is yes. Okay. So ML is based on previous data, maybe. Okay. Now, general observation will be, if yesterday it was warm, today also it will be warm, right? It cannot happen that yesterday it was hot and today it is snowing, right? Yesterday temperature was 30 degrees Celsius and today it is minus 20 degrees Celsius. That cannot happen, right? But there is some dependence or some correlation. I wouldn't say dependence, but some correlation is there. So there is some dependence. Some dependence is there. By the way, correlation implies that dependence is there, right? If two things are correlated, then they must be dependent. Okay, so are xd and xd minus 1 independent? Answer is no. But if I create a model, assume a model where probability of xd comma xd minus 1 is equal to probability of, what is the meaning of independence? Can somebody say? If they are independent, what can I write?
Probability of XD.
XD, okay.
Multiplied by probability of XD minus 1.
Yes, multiplied by probability of XD minus 1. Okay. So in general, what we have is generally probability of xd comma xd minus 1 will be equal to what? Will be equal to what? Probability of xd minus 1 into probability of xd given xd minus 1. And if they are independent, then this thing is equal to xd only. So you have like this. So basically your xd and xd minus 1 are totally independent, no dependence on each other. This is if I assume this as my model, then this model will not be very well able to model my distribution, right? On the other hand, a better model. Okay, how do you say a model is better? A model is better, how do you say? So you have observations. Observed samples, right? What are they? let's say temperature on day D, temperature at D minus 1, temperature on some day D minus 2, so on. Let me not call it D, I will call it as 1, 2, 3, something, so that you don't get confused. T0, T1, T2, T3, like that. So we have all these temperatures available. So if I call this as my XD, and this is my XD minus 1. And this model, and another model is this. Okay, if I extend this model, basically I want to say what is probability of XD comma XD minus 1 comma so on, XD minus some capital D, some, I want to model, let's say 50 days data. Then I will, or this is entire data which I observe. Let's say this goes on up to D minus. Can I say this is equal to probability of X I product I equal to D2 or D minus capital D. It should be also okay. Minus 1. Whatever, just it's fine. The details are fine. 2D. This is my model, right? This model, the number of parameters that will be required will be some value, some small value. But if I take another model, which is P of X D, comma, so on up to X D minus capital D plus 1, this is equal to probability of X D minus capital D plus 1 times product probability of some xi given xi minus 1 I equal to d minus d plus 2, so on. So basically I have assumed, okay, let me draw it more graphically. The temperature today and temperature yesterday, if they are independent, I model this node only. Probability of any xd will be, so basically this p will be same as this p, right? I will model this as only one p. Okay. P of x, and the same p of x can be used for this, for this, for this, for this, and so on, right? But this is model number 1. This is the model number 1, and this is the model number 2. So model number 2 will be something like this. You have x d minus 2, x d minus 1, x d, and there is a dependence. My xd depends on xd minus 1 only, does not depend on xd minus. See, probability of xd given xd minus 1. Basically, this means probability of xd given xd minus 1, xd minus 2, so on up to whatever number. This whole thing is equal to simply probability of xd given xd minus 1. That's it. It does not depend on the previous observations. Means my today's observation is just dependent on yesterday's observation. And if I know yesterday's observation, I do not need any other observation to estimate the probability of my today's value, today's observation. It could be anything. So this is called a Markov chain. Now I could also make a third model, which could be, so this thing will be modeled by See, what do I need? I just need probability of X, some I, given xi minus 1, I'm sorry, given xi minus 1. That's it. And when the chain starts, that's some original px naught I will need, right? See this one. When the chain starts, you need the initial starting probability and then you just conditional probability. You jump from this state to that state. Okay, let me see. Anybody has any questions in the chat window? Okay, good question by Darshit. He's asking, can we have some real life examples for the second model? Good question, good observation. Let me first write third model also. Third model could be d minus 2, x d minus 1, x d. Now, my xd is dependent not only on xd minus 1, but also dependent on xd minus 2. And similarly, my xd minus 1 is dependent on xd minus 3 and xd minus 2, but independent of previous things. So what I need, I just need probability of x. Okay, okay, I will first complete it and then I will tell you some. Okay, so, right, now, let me give you some real example for so that you can appreciate this more. Okay. Okay. You give me example where my current observation. Okay. Assume x to be a discrete variable. Assume x to be a discrete variable. Don't take continuous variables. Just take it as discrete variable. Now tell me a real example of today. Give me real life example of a case where first model will be sufficient. First model will be sufficient. Basically, which means all the observations are independent. Coin toss or dice throw. Very good. Very good. So if I am tossing a coin, so I may get a long list, xd minus 1, xd minus d plus 1, so on. But I know ultimately everything is independent if I know probability of x. Let us say if I know this is equal to 0.6 for heads and 0.4 for tails, if my coin is a loaded coin, a biased coin, then I know if I just know this model, if I just know this much, I can randomly generate the entire sequence, or I can model the entire sequence. Right? Now tell me how many parameters are required. How many learnable parameters are there in this model? How many learnable parameters are there in this model? Who can answer? I have modeled my observations as independent and identically distributed. And there are two states, heads and tails. So my random variable x has only two states, h and t, heads and tails. Tell me, and I'm modeling it, basically it's a discrete random variable. How many parameters do I need to which I need to learn from data? Answer is 1. Very good. What is that? That is basically p. If p of x is p of heads is p, basically p of x equal to heads. If this is p, then P of x minus x is equal to tails will be 1 minus P, right? So this is correct answer. We need only one parameter to learn. Now let's take some example. Okay, you can model this with second model also, but that won't help, right? What is the probability? Okay, let me ask you the question. What is the probability that x at time t, or let's say on, I'm using d, okay, let me use I is better, I think. xi is heads, given xi minus 1 was heads. What is this probability? Let me see who will answer. What is the probability that xi is heads given xi minus 1 is heads? P 0.6. Yes, the answer is correct. It is P. (0.6). From our this example, it is 0.6 because this is independent. Basically, this thing is equal to probability of xi equal to heads. This part is not relevant because these two are independent random variables, right? So, okay, I think these are very simple exercises. I'm just doing it because you have seen the lectures. I'm just trying to relate it with real life, that how you understand what we are doing. Okay, now, so in this case, a second order model is not required, only independent model works. Let me now tell me some phenomena which has to be modeled with a second order model, basically, or you can say where you, it's first order. Actually, this is called zeroth order model. This is now first order model will be when you are dependent on one previous step. Can you give real life example for this? A real life example. Okay, let me try to give you one example. You may like it. Let us say we have. Let us say I am on this grid. Waiting call. Abhishek has said waiting call. I don't know what does that mean. Let us say a man is sitting here, right? And this is a grid with indices 1, 2, 3, 4, 5, 6, 7, 8, up to 16. A grid with indices 1, 2, 3, so on up to 16, right? 4, 8, 16. And the man goes from here to here. So probability that at x of t, let's say at some I, is this number. What is the probability that xi is 4? What is the probability that xi is 4? So in order to come here, he can come either from here or here or here. And let us say it makes every change with an equal probability. Let us assume that. Now, what is the probability of xi equal to 4 given xi equal to xi minus 1 equal to 3? This is how much? How much? What is the probability that he's here given that earlier he was here? 1 upon 2 or something else? He can make only left, right, up, down, 4 moves. Left, right, up. But okay, here there is a wall, so he cannot go up. So only moves possible are left, right, and down. 1 by 3. Very good. 1 by 3, because he has 3 moves possible here, here, or here, and he will equally make his choice, like with an equal probability, and he can go. So pxi equal to 4. Now, what is the probability that xi equal to 4 given xi minus 1 was 7? 0. Very good. Now, what is the probability that xi equal to 4, sorry, when xi minus 1 equal to 8? 1 upon 3 again. Very good. Actually, now p of xi is equal to 4 given xi minus 1 is equal to anything, like any y is equal to 0 when y is not equal to what, 3 and 8, or it does not belong to this set, right? So basically I need to be able to know this value. So this is the first order Markov model, or where I need first order property, first order Markovian property to model my distribution. If I model simply without anything, like without any knowledge, I will, let us say, if I try to model it with the first model, what will I get? Probability of any x is equal to how much? 1 upon 16. To the second model, I will get probability of xi given xi minus 1. This is equal to, depending on whether it is in the middle or in the corner, or where are these two xi and xi minus 1, there will be different numbers associated. How many numbers are required? How many numbers are required in general? How many numbers are required? In general, how many numbers are required? So xi can take 16 values, xi minus 1 can take 16 values. So total how many? So okay, this one, number of parameters for this model. There are 16 values, so 16 minus 1. And here number of parameters. How many parameters are required? So xi can take 16 values, this can take 16 values. So 16 into 16 minus 1. That is a number. 16 square, I need 256 minus 1, 255. So you need 255 parameters to be able to model, to be able to use second order Markovian property. Okay. So, but if I have to use third model, which is my probability of xi given xi minus 1 comma xi minus 2, how many parameters do I need? Number of parameters. If my making a jump from here to here depends not only on this cell, but also on the previous cell. If I from here to here, then I go here, here to here, I go here with less probability because of momentum, I don't know, momentum or whatever. But then number of parameters will be how much? 16 values for this, 16 values for this, 16 values. Oh, I think Abhishek has pointed out a very nice point. Okay, but okay, it's fine, because here you're saying it will be 16 minus 1, which is also fine. But okay, what is, if I use, if I won't do this, because what is the probability that xi equal to 4 given xi minus 1 was also 4? What is the probability on staying on the same state in two successive time steps? That you can say 0, or you may give it some value. That is up to you. You have to make a model consistent. So, but here the number of parameters will be 16 cube minus 1. Why -1? Because you know that all these terms will sum up to 1. So there is 1 degree of freedom less. Because if you know 16 cube -1 terms, the final term you can find just by 1 minus all those terms, right? Okay, so this is the thing. This is the Markovian property. So coming back to our own original example, that the temperature today, it depends on yesterday's temperature, but it may also depend on day before yesterday's temperature. You can take it as velocity model and acceleration model, right? Let us say in dynamics, in our kinematics, we have Newtonian mechanics. My position is dependent on current position as well as previous position, basically current position and the velocity. And that is one model which does not take into account acceleration. But there can be another model where you also take into account acceleration, which means current position, and previous to previous position also in discrete domain. You're taking into account acceleration as well. Now, there could be rate of change of acceleration also. Although in physics, we don't use that model, but who stops you from using it? So basically, your model will be a third order Markovian property. Basically, it means you have you need uh, uh, your x dot, x double dot, and x triple dot, right? So I think that is the thing. Okay, now coming to hidden Markov models. So what are hidden Markov models? Hidden Markov models basically means my temperature depends not only on my temperature does not depend directly on the yesterday's temperature, but it depends on some underlying states. Let us say the weather. So the model will be something like this. My temperature or my x depends on, so let's say this is my x d minus capital D, sorry, d minus 1, x d minus 2, and x d. Let us say my xd does not depend on d minus 1 directly, but it depends on some hidden variable which has the Markovian dependence. Let's say this is z of d. This is a z of d minus 1. It's a hidden variable. Let us say, for practical example, it could be the season. My season today depends on yesterday's season, but once I know what season it is, then I can just randomly sample and I will get my xd. So this is the kind of dependence tree which we get. This is the dependence graph, you can say. So my temperature today, it depends on whether it is, let us say there are 4 seasons: summer, winter, spring, and fall. So let us say today is it's what season? Almost winter. Let us say this is winter season, and the distribution of temperatures will be independent of anything else if I know that today is winters. So my model will be simply probability of temperature. Oh, sorry, temperature I'm denoting with x. Probability of my temperature today, temperature on any day, given the season. But the seasons are interdependent. If today is winters, it is not possible that yesterday was summers, right? Because first summer comes, then fall will come, then winter will come, then spring will come, then again summer will come. So today is winter, then yesterday cannot be summer, and it cannot be spring also. It might be fall, because fall can switch to winters. Probability of x given z, and I need probability of zi given zi minus 1. Okay, so this is the thing this is the thing that you can try to understand. So this is the Markovian property. I think we have discussed the mathematics in the lectures and the videos. So this is the thing. you have a chain of observations or a chain of random variables which are at different time instants, and the observation at one time instant, it depends on, like, this one depends only on the previous time instant observation. It does not depend on the previous to previous. X1 does not depend on X4 does not depend on X2. It depends only on X3, which means if I know X3, then my PDF of X4 is decided, it is fixed. Then I have mth order Markov chain, means it depends on m previous values. Okay. Now, so this is the latent variable model. Basically, my observation is dependent on the latent variable, which is the season, let us say in this case. And I have hidden Markov models. So the property of this model is that my X could be either discrete or continuous, that is all right. But my latent variable must be discrete. Let's say we took the example of seasons. My seasons must be discrete. There are 4 seasons, and they are discrete. Z is a discrete random variable which can take 4 values, but my temperature today can take continuous values, as many as I want. Okay, and there were some examples, some more examples, like speech recognition. When I'm speaking, so let's say when I'm speaking, I'm saying E. You look at my sound audio, it will look like a pattern. When I say S, then the pattern will be something very noisy kind of S. And when I say E, per will be some click and then per. E, let's say like this. So basically my pattern here is dependent on previous, let's say this pattern is dependent on the previous pattern, because I'm seeing E. So this pattern will be very much similar to this pattern. But this pattern, when I say then since here it is this noisy, here also it will be noisy because of that dependence. And of course I can make transitions between phonemes. This per and this is E. Sorry. Speaking. So these are my discrete random variables, the Z, the phonemes, the discrete random variables which I can take, and this observation is a continuous observation which I'm having. Okay, this basically, I'm not working with the raw audio, but I will extract some features. Let us say band energy. So let us say this is a vector of band energies. Here you have high energy in the more energy in the higher bands, higher frequency bands, and here you will have some distribution, maybe lower energy. Here you will have some other distribution, like you will have a formant kind of structure. So, and then in video classification, assume Z is a gesture. So let's say if I'm moving my hand, so if my hand is here, previously my hand would be here, 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 or here, but it cannot be here, right? It cannot make a discrete jump from here to here. So my observation is a continuous random variable, but my underlying states, if I want to use HMMs, they must be discrete random variable. For example, I am saying hello, or I'm saying thumbs up, or I'm saying thumbs down, or I'm saying I'm asking a question, right? But it is not, means, so basically these could be my underlying states. My state is either I'm saying hello, or I'm asking a question, I'm saying thumbs up, or I'm saying thumbs down. Like these 4 states. And now my observations will be derived. Once I know that I'm doing like this, then the distribution is pretty much fixed. My hand will be in this configuration. It cannot be like this. If I'm saying hello, my hand cannot be like this. It is very unlikely, right? The probability is very, very less. So I can use the HMM model for video classification also. Observations are continuous, and the hidden variable is discrete. Okay, now, yeah, there is a lot of mathematics involved, but I have tried to simplify it for you. Okay, so when you say this is called transition probability, when in the first order Markov model, it transitions from jth state to kth state. j state to k state. From at time n minus 1 it is at j state, time n it is at k state. That transition probability could be stored in a matrix. Like here you saw in this, the number of parameters required is 16 cross 16 minus 1, which means it needs only 255 parameters. And these parameters could be stored in a matrix, right? A 16 by 16 matrix. And so this is state transition probability and emission probability. Now, when you say Px given Z, so basically you have modeled your, so okay, let me come to this example now. Let me just separate it out from. Okay, so in the first order Markov model, I will say this is my emission probability. Emission means you know the season, and you're predicting the temperature. You know what phoneme it is, you're predicting what is the energy band, or energy vector in frequency band, basically spectral vector. And you know the underlying gesture, and you are emitting what is my image. This is the image, this is the underlying gesture which I'm making. So this is called emission probability. And this is called transition probability. If I'm making handshake, if I'm doing hello like this, what is the probability the next state will also I stay in hello, or I go to question, or I go to thumbs up, thumbs down, right? So I think this is called a transition probability. I'm transitioning my state, discrete state. I ask a question. Can you quickly draw this matrix, or at least you can tell what entries will be 0 for when the states are the seasons? There are 4 seasons. Tell me how the matrix will look like approximately. At least you can tell what values will be 0, what values will be non-zero, what values will be large, what values will be small, right? Assume that these seasons are coming in succession. First summers, then fall, then winters, then spring, again summers, fall, winter, spring, like that. So this ordering is decided. It cannot happen that winters are coming after summers. Okay. So tell me how the transition matrix will look like. Okay, first of all, tell me what will be the dimension of this matrix? It will be summers, then fall, then winters, and then spring, and then again summers, and again fall, winter, spring. This is the kind of succession which we observe. But how do you model it in your transition probabilities? Can somebody tell me? Is it too difficult? Himanshu is asking a question. Can hidden variable take infinite discrete values? Answer is no. I have never seen such models where there are infinite number of discrete values, because we are trying to track the probability of each value, each state. And if there are infinite number of states, and the probabilities will change. Yeah, but theoretically, yes, it is possible, but I have never seen it in any practical scenario. If there are infinite number of discrete values, how many parameters will be needed to make this model? Infinite number of parameters also, right? Because then transition matrix itself will be infinite dimensional, and your emission probabilities will also, you will need an infinite number of PDFs to model your emission probabilities also. So practically it is not seen, but yes, theoretically, who stops you from doing that? Okay. Any suggestions? Okay, tell me what is the dimension of the matrix Aij? Yeah, Yash is answering something, which looks good. Tell me the dimension of Aij. 4 cross 4. Very good. Yes, this will be a 4 cross 4 matrix. So you will have 4 entries, 1, 2, 3, 4. Okay. Tell me now, what are those matrices? Let us say this is summers, fall, winter, spring. Summer, fall, winter, spring. Okay. So what is the probability of, let's say this is my I, this is my J, and I want to model probability of, let me check whether they are probability of Z equal to I given, this is the time T, I'm just D. And this is my A matrix, Aij. This is basically okay. P. This is the thing. I am going from J to I. J to I. So what is the probability that today is summer when yesterday was also summer? It will be a very large value. Let us say 0.9. Right. What is the probability that yesterday was a fall and today is a summer? Fall to summer. Fall to summer. Probability is 0. Yeah, because we have said fall leads to winter, not to summer. This will be 0. What is the probability winter to summer? 0 again. Spring to summer. Spring to summer will be, how much will this value be? 0.1, 0.1. Okay, are you sure this will be 0.1? It will be some large value. I don't know how much will that be. Okay, somebody is saying 0.1, but I will show you later. It is not 0.1. It need not be 0.1. It could be 0.05 also. 0.05. It could be. Okay, let's go to the last column, last row now, you'll understand. What is the probability of, okay, let us do the first column first. Summer to fall, what is the probability? Summer to fall probability is something non-zero. How much will this be? This value you have to tell. Okay, summer to winter, probability is 0. Summer to spring, probability is 0. Now tell me what is the probability summer to fall? Okay, what is this column? What is this column? This probability of ZD is equal to I given ZD minus 1 is equal to summer. And this is a valid PDF for I. So if I do a sum over all I, it should be equal to 1. Right? So my column should sum to 1, not the row. My column should sum to 1. So this will be 0.1. And similarly, you can do the same exercise, but the point which I wanted to make is very clear that my column should sum to 1, not the row. Because go by logic that this is the thing what we are writing here. The column is this, and these should sum to 1. But if I take the row, what will this be? This row will be probability of that my, this is J is changing, I is fixed, that my ZD is summer given ZD minus 1 was some J, which is one of these four. Now, if I sum over all J, can I say this is equal to 1? No. Need not be 1, right? It could be anything. Doesn't matter. Okay, I think I went into many nuances, many details, but I think you get to know these when you listen to the lectures. So we meet next time. But I would suggest I will share the test cases and the program with you. Run the program, and that will help you to see your mistakes properly. If you still have some questions, then you write on the forum and approach the TAs. They will clarify your questions. Thank you. Thank you very much. Okay, I can stop here.